Namaste and welcome to lecture 4 of triangles. Today we will be doing some sums on SAS postulate. Okay. Here I have written a sum that is in triangle ABC, line segment AB is congruent to line segment AC and the bisector of angle A intersects BC at D. So first of all, we should draw a figure related to the statements given to us. It is given in triangle ABC. So let us draw ABC first. AB is congruent, line segment AB is congruent to line segment AC. Okay. Now the bisector of angle A intersects BC at D. Now see, you should know exactly the meaning of bisector and also what does this bisector do. Okay, so first we will write, I would like to explain you what is bisector of a triangle. See, what is a bisector? The bisector in a triangle is a line that cuts an angle, okay, or side into two equal parts. Got it? Now, a bisector in a triangle is a line. This is a line that cuts an angle. It is cutting an angle and the side BC into equal parts. Okay. Now they have asked us to prove that this AD is perpendicular to BC. We also have one definition, that is perpendicular bisector. What is the meaning of perpendicular bisector? Means if a line divides one of the triangle side, okay, into two equal halves at 90 degrees. Now see, what we want, you should first understand the statement of the given sum. The bisector of angle intersects BC at D and we have to prove that AD is perpendicular to BC. Now for AD is perpendicular to BC in this triangle, we have to prove that this is 90 degrees and this is also 90 degrees. Then we can say that AD is perpendicular to BC, or it must be given to you that it is 90 degrees. Then if it is perpendicular, then this is 90 degrees. But here we have to prove. Why this? Because the definition of perpendicular bisector is what? See, basically why we are not able to do this kind of sums? Because we don't know the terms which were taught in class 7 or 8. Okay? Now see, perpendicular bisector is a line. It is a line that divides one of the triangle's side into two equal halves at 90 degrees angle. Okay, it is a line that divides a triangle's side, that means this side, into two equal halves at 90 degrees. So if we prove that these two angles are 90 degrees, then we can say that AD is perpendicular to BC. So first we will write what is given in this sum. That is very important. It is given that in triangle ABC, line segment AB is congruent to line segment AC. Okay, and it is also given that the bisector of angle A intersects BC at D. This much it is given to us. Now we have to prove that AD, line segment AD, is perpendicular to line segment BC. Okay, so we shall prove that two angles 90 degrees. And what will we do? One thing also, then we can say we have to prove two sides and one angle also to show the correspondence of a two triangles is congruence. Let us do, you will understand. See, now if I want to show that the correspondence of triangle ABD and ACD, this correspondence is a congruence, then what will I do? First I will take triangle ABD and triangle ACD. Let me draw triangle ABD here. See, let us draw the figures separately so you can understand. Okay, and the another one is ACD. Got it? Now here it is given to us that this side is congruent to this side. So here it is already given that line segment AB is congruent to line segment AC. This is already given to us. One side is they have given to us. Secondly, we can say that because this AD that is also given, that it is the bisector of angle A. Okay, so what can I say? These two angles are equal because it is a bisector, means it will cut the angle in two halves. Okay, what is, see, this is nothing but here we will use the term of angle bisector. At last I will write that definition also. Now here in these two triangles we can say that this side is congruent to this side. Now angle BAD is congruent to angle CAD. Why? Because AD is the bisector of angle A. Got it? And one thing is already given to us by the figure only, we can say this AD is equal to AD because it is a common side. Line segment AD is congruent to line segment AD. Why? Because it is a common side. Yes, or you can say same line segment. Okay, now see, you have already proved one angle, two sides. So this is side, angle, side. So we can say that therefore the correspondence ABD to ACD is congruence. This is by SAS criteria. Okay. Now see, we can say this figure we know now. Now we can say that ADB is congruent to ADC also. Yes, as we are proving this correspondence, I can write therefore angle ADB is congruent to angle ADC, and let me give why this, the reason, because of the correspondence. Okay, now see, as this is congruent, we can write measure angle ADB is equal to measure angle ADC. See, this angle is equal to this angle. Okay, now one thing we can notice that it is like this, B, D and C. There is a line like this and it is making an angle. Now this is a linear pair. It is making a straight angle. Correct? This is a linear pair. So what can I say now? Angles, here it is A, correct? I can say that angle ADB and angle ADC are angles of a linear pair or a straight angle. Okay, why? Because it is in a straight line B dash D dash C. So what will this angle be? This whole angle be 180 degrees because it is a straight angle or it is making a linear pair, correct? So therefore we can write that angle ADB plus angle ADC is equal to 180 degrees. But this, if I say 1, from here I can say that these two angles are equal. So we can write angle ADB plus angle ADB is equal to 180 degrees. Why? Because from sorry, 1. So this is what? But 2 times measure angle ADB is equal to 180 degrees. So measure angle ADB we will get 90 degrees, which is also equal to measure angle ADC. Why? Because both the angles are equal. Now as we have proved that this is 90 and this is 90, where we have proved now? In this triangle. We have proved that this angle bisector is, these two angles are 90 degrees. So I can say that AD is perpendicular to BC. Therefore, line segment AD is perpendicular to line segment BC. Why? Because we have proved that these two angles are 90 degrees, and according to the definition also of the perpendicular bisector, okay, it divides the angle into equal halves. Now I say that I will show you the angle bisector definition also. See, these terms are very important for you to do this kind of problem sums, this kind of proofs. What is an angle bisector? See, angle bisector of angle A intersects BC at a point D such that ratio of line segment BD is equal to the ratio of line segment CD. Okay. Also we can say that it is a line that divides the angle into equal or congruent angles. Okay, it is a line. That means if this triangle, it is said that bisector, then this angle by it is a bisector of angle A also, which is dividing into two equal angles. It is dividing the angle A into equal angles. Okay, so these terms you should remember always. Now I end my lecture over here. In next lecture we will do more sums on SAS criteria, and then we will go to the next postulator criteria. So thank you very much.